In this experiment, we'll be controlling a photoresistor using PID control. The input is taken from the photoresistor and is like passed through the Arduino. So the photoresistor is connected to the fourth analog pin, that is A4. A resistor of 10k ohms is used to connect it. We have an LED bulb which is connected to a 330 ohms resistor, and it is connected to the digital pin 7 of the Arduino. We also have a potentiometer which is connected to the analog 5. I'll be showing the code for this right now. In the code, we can see that the photoresistor is connected to the fourth analog input, so it's given as A4, and the LED pin is connected to the 7th digital pin. So now we set the variables. Int actual. Actual is the actual value taken from the photoresistor. The desired value is set through the potentiometer. Initially, the error is initialized as 0. All the D errors, I error is also initialized as 0. D error is from the differential and the I is from the integrator. The previous error is one calculated, like after one loop, the whatever error is from the previous value, it is added. So the gains are Kp, Ka and Kd. These are the gains we set for this experiment. In the void setup, we set the LED pin as output, and then the serial monitor begins, like serial monitor is initiated. In pin mode, we then set the photoresistor as input and the LED pin also as an input. Okay, in the void loop, we can see that actual is taken from the analog reading of the photoresistor, and the desired is taken from the analog reading of the A5. A5 is the potentiometer. Error is calculated by subtracting desired value minus the actual error. So next, the sensor value is calculated using error times Kp plus D error times Kd plus I error times Ki. Next, we print the following in the serial monitor. So we print P error, I error and D error. Now this is done to avoid non-negative values. So we set if sensor value is less than 0, it is equal to 0, and if it's greater than 255, sensor value is equal to 255. Then we print it as command in like sensor value. And to turn on the LED, we use analog write, which takes from the LED pin and the sensor value. So the D error is calculated as error plus minus previous error, and the I error is calculated as error plus the previous error. And previous error is replaces error from the every time. And we give a small delay of 50 milliseconds. So we'll just run the circuit right now. So we get the following in the serial plotter. So as we increase the potentiometer, you can see that, so we decrease the potentiometer, you see that the value keeps decreasing. And this is at the 0 position, and the LED is off.